Well, greetings, everybody. So today I thought it'd be important to talk a little bit about graphs. And here I've drawn a basic graph. I drew it by hand, so it's not perfect. But a graph will look something like this, and it will have all these features that you see here. So let me talk about the features. A graph is made by two axes. There's the horizontal axis, or the x-axis, and it gives us a way to measure left and right. Okay? So I can go right one space, right two spaces. I can go left one space, left two spaces. You see that the positive numbers are on the right, the negatives are on the left, and zero's in the middle right there. So this -3, that's left three spaces on the x-axis, for example. Okay? If I was right in the middle, then I would be at 0 on the x-axis. We also have a y-axis. The y-axis is also called the vertical axis, and it allows us to travel up and down, or we can measure up and down. I can go up 4 spaces, and I would say I was at 4 on the y-axis. I can go down 2 spaces, and I could say I was at -2 on the y-axis. Positive numbers mean up, and negative numbers mean down. Okay? Now, if I put all this together, it gives me a way to locate a point. Okay? So say this point is right here on my graph. How would I describe to you where that point is? Okay, so the way we describe where a point is we give its coordinates. Okay, so if I have these two numbers separated by a comma and enclosed in parentheses, that's the coordinates or the address or the location of that point. So there's that point. How would you get to this point by moving left and right or up and down? If I was to get to this point, I would go right 3 spaces and down 4, and I would be there. So that's the location of the point. So that's what this 3 and -4 tell us, okay? That's the location of the point. It says you can get to this point if you go right 3 spaces and then you go down 4, okay? So that's how we specify where points are. Now, if I say go right 3 and down 4, I mean from this point that's right there in the middle where the two axes meet. That's called the origin. You always start there. So I implied that when I described this a minute ago, but yes, to get to this point, you start there in the middle at 0 for x and y, and you go right 3 and then down 4. Okay, so always start right there at the origin, and then you can go left and right or up and down according to the point. Okay, now just in general, I've implied this in my first example, but in general, points look like this. That first number is the x coordinate, and you would go left if it was negative, and you go right if it's positive. And the second number is called the y coordinate, and you would go up if it's positive and down if it's negative. So that first number tells us left and right, and the second number tells us up and down. And just like the address of this point, I can interpret it as, right 3, down 4 in this case, and in general, like that. Okay, so let's see some examples from the assignment at this point. Let's just open the assignment. I'll show you the kind of interface that we get in this assignment, because we'll have to understand what the numbers mean, like in my whiteboard right here. I can understand, like, what's the 3 mean and what's the -4 mean? What's that supposed to do? But we're also going to have to learn how to use the graphing interface in the assignment. So look at this. It says plot the point 5, 2. So that's the address of a point. That tells me where it is on the XY plane over here. So the graph, the grid, the X and the Y axis together, that's what I was trying to draw when I drew this. I drew it by hand, so it's not perfect, but I was trying to capture this. See, it's got all the same features, but it's got a grid overlaid on it so you can count a little bit easier. Okay? So anyway, it says to plot that point. So I would understand this point as I start at the origin, and then I go right 5 and up 2. So let's see, can I maybe drag this point over there? There's right 5 and up 2, and that's where I want it to be. Okay, I look at this, it's pretty easy to tell that it's where I need it, right 5 and up 2. So I can just use the graph and I can put it there, okay? All right, so it's that simple with the most basic questions here in our assignment. Okay, let's look at something else. Let's look at a specific problem being question 4. Okay, so let's say given that we can graph like a basic point if we need to, like in that question I first showed you. Okay, so I'd like to do this one. Okay, it says here I have an equation, and if I have that equation, it has an x and it has a y in it. So that equation contains a bunch of points, because all a point is an x and a y together, right? So like over here, we call that first number the x coordinate, or the x, and the second number the y, and they tell us points, and they tell us left and right and up and down and so on. So every equation that has an x and y in it has lots of points contained in it. And the thinking here is maybe if we pick some, generally at random, it'll form some kind of a shape. Now, all the equations and all the points they contain in our assignment will always be lines. It's a very simple shape. With just 2 points, you can see what it looks like. It only takes 2 points to draw a line. So this is a line. I want to figure out 2 points on it. And the way I'm going to do it is I'm going to let x be 10 in that equation, and I'm going to let x be 90. I'll get 2 points, then I'll draw the graph. Okay? So, all right. Let's look at it on my whiteboard. So I want to find 2 points on this graph, okay, through the equation. They gave me that x is 10 and x is 90, and I'm going to see what that gives me for y. The equation says y is 0.275 times x, then plus 8.25. So if I know what the x is, this equation gives me a way to figure out what the y is supposed to be. So as the problem said, I used 10 for x and 90 for x. I put them in that equation. For example, if x is 10, I do 0.275 times 10, then plus 8.25. I use my calculator. That turns out to be 11. What that means is this equation contains a point where x is 10 and y is 11. Now, all the points in the equation may form a straight line. I can't draw a line if I just know 1 point on it. So they gave me another point, 90. If x is 90, what's y? I put 90 in for x in that equation right there. I did the same thing. I got 33. So there's another point. This line also contains a point where if x is 90, y is supposed to be 33. So look, I got 2 points. I know how to graph any point. This first point, for example, is to go right 10 and then up 11. I can plot that point. The second point, go right 90, up 33. I can plot that one. And they'll make a line, and then I'll know what it looks like. So that's the objective here. So let's see. Let's open question 4 again. Okay. Now I know what my points are supposed to be. Right 10, 11. Right 10, up 11. And then right 90, up 33. Let's graph them individually. I'll have to click this to enlarge the graph. Okay. All right. Now, in order to locate the points, I select the point tool, and then it will allow me to locate a point somewhere. Okay. All right. So what was that first point? It was right 10 and then up 90, or up 11. Sorry. So let's see. I got it right 10, and then I'm going to very carefully move it around until it's up 11. Okay. So there it is. See how the coordinates showed up there as I moved it around? So even if I couldn't see this graph perfectly well, if I get it close, I can just look at that and see if it's where I need to be. Okay, so I got that point. Where's the other point? Right 90, up 33. So right 90 and then up 33. I need to put it somewhere over here. So I select this again. Right 90, right 33, up 90. I'm going to have to be very careful if my hand is a little shaky. There we go. All right, there it is. Right 90, up 33. Okay, so I got it. All right. Okay, so those are my 2 points, and you can see that a line does form between them if I have 2 points. All right. Okay, so I got that. I found what the points are, and I put them where they're supposed to be, right? I saved it, and there it is. Okay, so that's what I needed to do on that one. If the problem happened to say that to draw a line through those points, then there will be a feature on the graph where I can do that. All right, but as it is, that's what this one said. But let's do another. Let's do another one where maybe it gives us a little bit more instructions. Okay, so I want to do, which one was it? Question 11. Okay, it has the same strategy. I'm given an equation, and this time they give me 3 points. I'll graph all 3 points and see if it makes a line like it's supposed to. Okay, all right, so let's see. Question 11, you'll see it. It's going to open and it's going to give me this table where I make the points first. Okay, so see, it says find 3 ordered pair solutions. That means find 3 points, find 3 x and y pairs for this equation. Y is 6 times the x. Okay, I'm given these x's of 0, -1, and 1, and I find the y's. All right, so in any case, that would look like this, right? I have an equation. It says y equals 6 times x, and I'm given x is 0. So that would make y 6 times 0, which is 0. So I get my first point, 0 for x, 0 for y. I'm given x is -1. That would make y 6 times -1, or -6. As a result, if x is -1, y is -6. And then I'm given 1. Y is 6 times 1, or 6. Okay, so I get a third point, 1 and 6. Now, what's that mean? This point, for example, -1, -6 means I would go left 1 and down 6. So this line, that's what that looks like. If you collect all the points together, you can see it with just these 3 points. If I plot these 3 points, they'll all be on a line. Okay, well, let's see that. So I'm going to open this back, and I'm going to plot that graph over here. All right, so open this. Now, in this graph, I'm not just going to plot the points like in the last question. I'll see that they form a straight line. So I can select all of these shapes that a graph might be, and what I want to select is this one. See how when I hover over that, it says line tool. So I click that, and then I'm going to plot the points that I have. Remember what those points were? There was one at 0 for x, 0 for y. That's right there at the origin. There was one for -1 for x, -6 for y. Okay, there it is right there. Okay, and then I could plot this third point, but it turns out I don't need to, 1 and 6, because how many points do you need to draw a straight line? You just need 2. 1 is not enough. 3 is more than you need. So when I was going to plot this, I just selected 2 points from my table. Okay, and it comes together, and that's what it looks like. If I plotted the other one somehow, it would fall right on this line. Any points I find out of the equation are going to be on this line. Okay, so I save it, and it's supposed to look like that. All right, well, so let's check it. And then we'll be done. Let's see, check it, and of course it's going to be right. Okay. All right, so there's your crash course on points, graphs, and then if you have an equation, the points it contains, it will be a line in every problem on this assignment. There's one more or 2 more I need to show you just to make sure you see everything. So this one, it says, is this equation going to be linear? Meaning, are all the points that you would find on it, are they going to make a straight line? If you just have x and y with no other things like exponents or roots or anything like that, it's always going to be a line. Okay, so this is a linear equation. By that they mean, is it going to be a line? This one, same thing. I just have x and y. It doesn't say x squared. It doesn't say y squared or anything like that. It's just x and 6 times y. So anything like that's going to be a line. Okay, but what about this one? I see it just has y. It says 3y, but this time it says x squared. If the x has an exponent of 2, if it says x squared, if the y has an exponent of 2, you could find points. You could plug in an x and figure out what the y is supposed to be, but all those points won't make a line, okay? If there's an exponent, okay? So in that case, is this a linear equation? Will it be a line? Well, in that case, it won't, okay? Now, all right, so in any case, everything that you graph will be a line. But on the assignment, you might see these questions where it gives you an equation and it says, well, hypothetically, if you did graph all the points, would they make a line or not? And now you know how to address that too.